Matrices are fundamental tools in engineering and mathematics. One important question is, how much can a matrix amplify an input vector? The answer leads us to the concept of the induced matrix norm. In this video, we will understand what it is and why its definition uses the Supremum or the maximum amplification. This is the Control Geek and welcome back to a new video on controls. Matrix induced norm. Why do we need the Supremum? Suppose a matrix A represents a system. A vector U is the input signal, and after passing through the system, the output becomes AU. Naturally, we would like to measure how much this system amplifies its input U. This is exactly what a matrix norm tells us. If the input has length and the output also has length, then the amplification is simply the ratio between the output length to the input length, whatever this length is. If this ratio equals 2, the system doubles the length of the input vector. If it equals 5, the output is 5 times larger. So at first glance, this ratio seems like a good definition of the matrix norm. But there is one problem. The amplification depends on the direction of the input vector. For instance, if we consider the following 3 different input vectors and consider this matrix, each input vector will give a different output as shown. And when we compute the norm 2, for example, there will be 3 different norm values, each corresponds to the input used for the calculation. Note that these values are not equal. The same matrix produces different amplification depending on the input direction. So, which one should we call the matrix norm? Instead of choosing one particular input direction, we look at all possible input vectors. Among all these amplification ratios, we choose the largest possible one. This leads to have the so-called induced norm of matrix. This norm does not depend on the input vector, but it's determined solely by the matrix element. The symbol sup or Supremum means the least upper bound, or the maximum amplification the matrix can produce over every possible input direction. In other words, the induced matrix norm measures the worst case amplification of the system. This explains why the Supremum appears in the definition. Since the amplification changes with the input direction, the induced norm is defined as the largest amplification achievable. It provides a single number that completely characterizes the maximum gain of the matrix. Without going into the details, if you dig in the signals and system books, you will realize that the induced norm 1 of the matrix A is just the column that gives the maximum summation in its elements, while the induced norm 2 of the matrix A is just the square root of the maximum eigenvalue of the square of the matrix. And finally, the induced norm infinite is just the row that gives the maximum summation across its elements. So if we went back to our example and according to our definition of the induced matrix norm, we don't need to know the value of the input vector. We can calculate the norms by only using the matrix elements. Induced norm 1 is the summation of the second column as it gives the maximum summation. The induced norm 2 is the square root of the maximum eigenvalue of the transpose of the matrix multiplied by itself. And finally, the induced norm infinite is the summation of the second row as it provides the maximum summation. I hope this video helped you better understand the concept of the induced matrix norm. Before you go, I'd love to hear from you. Was this explanation of the induced matrix norm clear? Is there another topic in the linear algebra or control system you would like me to cover? Leave your thoughts in the comments below. If you found this video helpful, please like it and consider subscribing so you don't miss future tutorials. Thank you for watching.